For centuries, we believed reality was a clockwork universe, predictable and absolute. Every cause had a specific, measurable effect. The universe, we thought, was a story already written, and we were just turning the pages. Then, at the dawn of the 20th century, physics broke. The smooth, continuous fabric of reality began to fray at the edges. And from the ashes of classical certainty, the universe forced us to invent a new language to describe it: quantum. By the late 1800s, the edifice of physics seemed complete. From the motion of planets to the behavior of light, everything followed a set of elegant, unbreakable rules. It was a time of great confidence, a belief that we were on the verge of knowing everything, until the experiments started to fail, revealing cracks in the very foundation of our understanding. The first shockwave came with the discovery that energy wasn't a continuous flow. It came in discrete packets, or quanta. Then, the very building blocks of reality, particles, began to exhibit a ghostly duality, behaving like waves one moment and particles the next. Reality, it turned out, didn't just stop making sense. It started to play by a whole new set of rules. The quantum world was a realm of pure potentiality. Particles could exist in multiple states at once, a concept known as superposition. The simple act of measurement, of looking, would force a particle to choose a state, shattering the superposition and altering the outcome. And in the most bizarre twist of all, two entangled particles could be linked across vast distances. Their fates intertwined in a way that seemed to defy the very laws of space and time. Distance, it seemed, stopped mattering. This quantum weirdness wasn't just a curiosity. It was a clue, a signpost pointing to a new kind of reality. What if, physicists wondered, information itself wasn't just classical bits of zeros and ones? What if information could be quantum, existing in a superposition of states? And if information could be quantum, what if computation could too? Quantum algorithms revealed massive advantages. Problems once impossible became solvable. Quantum computers moved from chalkboards to laboratories. Cold, fragile, powerful. Quantum became strategic. Nations and companies raced forward. AI now stabilizes quantum systems. Quantum will soon accelerate AI. Quantum computing won't replace classical machines. It will expand reality itself. If you enjoyed this journey, subscribe to the AI and Quantum series. The next episode explores how quantum actually computes.